Okay, question 3 of the summer 2012 Physics Unit 1 paper. This section is on visible light, but also including some of the main ideas around telescopes and the use and advantages of telescopes. So, mirrors and lenses can be used in telescopes. Which diagram best shows what happens to a ray of light when it hits a plane mirror? A plane mirror means a flat mirror, and we should recognize the law of reflection. The angle of incidence equals the angle of reflection around this dotted line here, which is called the normal. The normal is always drawn where 90 degrees to the reflective surface. So we have an angle of incidence in here, and we should note that the angle of reflection here is the same. Those two angles are identical. I've focused on B because that is the correct answer. You don't have that situation in any of the other three pictures. Moving on to question B, the diagram shows light rays in a reflecting telescope and then gives you a basic picture of a reflecting telescope, focusing on the curved mirror or the primary mirror at the back, which we should remember is used for collecting light. The plane mirror reflects light through the eyepiece, and then there's the eyepiece, which I try to help students remember what eyepieces are for. The idea of eye, it's closest to the eye, the eyeball is here, we look through the telescope at this point here, and it's for magnifying. So the question asks us to describe what the mirrors and the eyepiece do to the light rays from an image, to how they form an image of a distant star. There's 3 marks for this question, and the basic ideas are: the curved mirror reflects the light gathered, or reflects the gathered light and focuses it. It's curved so the light bends in and starts to and comes together to form a focused point, which would be here where the rays cross over. That's the first point. Second one, the plane mirror here reflects the light through the eyepiece lens, so that sends this gathered light into the eyepiece, and then the eyepiece lens magnifies the image, so we see a magnified clear image of whatever the telescope is pointing at. 3 marks. Part 2, explain an advantage of using a telescope instead of the naked eye to look at stars. The key command word here is explain, so we need to have some sort of linkage here. So basic idea is that telescopes collect more light, they produce bigger and more magnified images, so they show stars the naked eye couldn't see, so they show us more stars because they collect more light and show bigger images of stars. You can also observe stars day and night. And other acceptable ideas, maybe where students would write things more simply, would be the images are brighter, clearer, they look closer, or the images look more zoomed in, so we can see further, and consequently we can see more stars in more detail. 2 marks. Moving over the page, and this now refers to the idea of how light travels through space. There's a model here of a particular type of wave, an up and down wave, and it's a slinky spring demonstration which all of you should have seen in your classroom. The first question is that to state what the name of this type of up and down wave is. Hopefully you recognise it is transverse. It forms an S shape, which is where we get the transverse from. All light waves travel in that sort of way. How could the movement of the hand be changed to make the amplitude of the waves bigger? And we've got an option here, a sequence of options, multiple choice, and the answer is C. Move up and down a bigger distance. So if you wanted to make the amplitude bigger, that is to make the height above the middle point or below the middle point bigger, you would move your hand up and down more, a bigger distance. Calculation question next. The wave shown in the model has a wavelength of 0.5 meters and the frequency is 4 Hertz. Calculate the wave speeds. The command word is calculate. Use the formula page, go back to the front of the booklet, and you'll find that wave speed equals frequency times wavelength. That's provided on the front of the booklet. Substitute in the numbers for 1 mark. 4 Hertz, that's the frequency, 0.5 meters is the wavelength. Come to an answer of 2. Substitute that answer in here, and that's your second mark.